Okay. Quick testing, validation, whether we are live or not yet. How's the audio? Okay. It looks like we're good. It's a bit of delay that I'm seeing from my phone, but I guess this should do. Okay, so yesterday I've posted a video, a photo and a screenshot of some statistics that I was looking into for the web vitals and whether I can instrument JMeter to report them. Maybe the first statement should be the problem that I was trying to solve. So we have teams dedicated for backend testing. So they are specializing in some protocols. They are specializing in the software saturation, software response times at the server side. There's whole observability around it built in right now so that we can dig down into each database call and all the external IOs that we are doing. And there's also teams dedicated for the front end and performance of the front end, and they rarely go in pair. This means when we have a set of test results, you're going to have a core web vitals score and you're going to have a backend score. If you don't test these together, or if you don't test your web vitals or user experience during a stable load, during an expected load, your results will not be matching the ones that your browser will start accumulating. So I'm trying to fill in this gap, and here's what I came up with. Let's see. Okay. First of all, we need some way to inject the web vitals library into the web page you're loading. So in here, this is just a copy full web vitals from the Google repository. So there's nothing new here, nothing special. It's just a web vitals library. The only thing that's new here that I had to add was the functions and what to do with those vitals metrics. Normally, Google would send these to their own endpoint for accumulation to affiliate and to correlate with your website. Since we will be working with test environments, we want these to be sent or extracted ourselves whenever we are running a test or something. Right, so this piece of code here just make sure we keep track of those vitals and they are ready for extraction. I'm using the local storage of the window. I'm not sure if it's the best way to do that, but that's the only way I could find so far using an extension. So the solution here is that I'm using a browser extension. So this Web Vitals JS lands as the browser extension. And later on, when I'm running a test, when I'm running a script, I can also address and extract these values myself on demand. So it doesn't store these values anywhere outside of the browser. Whenever I'm running a test myself, I have to make sure that I extract these after each action. So I'm going to show how it works later. And there's also a function to define how to retrieve these code vitals. And I have to make sure this function is available for whenever I'm executing a script. So I'm attaching it straight to the window object. I'm also not sure whether it's best practice or not. I've actually consulted ChatGPT to help me with that. So if you guys have any better ways to handle that. If you think that there is something more useful and more efficient, then let me know. Of course, some debugging. There's still this is still an experimental thing and experimental development, so there might be some hiccups here and there. And it gets attached whenever I am loading a DOM content when it was complete, right? So I'm just defining this this function, and that's pretty much it for the browser extension. And this all gets defined in here. So the backend JS, I think it's obsolete. I think I can just delete it because it was supposed to. It was my first attempt to correlate the extension and the browser session somewhat. I wanted them to communicate with each other, but it failed. Also, one of the problems with GPT that doesn't like give you the right answers. So this just failed. So I'm just at the document start. When the document starts loading, I'm injecting the web vitals right away. And after it's completed, I'm defining the functions to retrieve those web vitals, right? So they are stored at first when we start load the document, and after it's finished, so that I don't block the render queues anywhere, I don't block the rendering of the page. After it's completely loaded, I'm just adding those functions to the browser. So how is it done? Because JMeter is normally working on a protocol level. So whenever you do a recording of the browser session, when you have to click through, the pages, and then you do have to do correlations of those pages and parameters. So this effectively rules out any way of rendering your browser. Right, and there is no rendering of the JMeter normally, so I had to use a Selenium plugin that actually opens up a Selenium WebDriver. This acts as my browser, so I can just inject those metrics there, and once I have injected them, I can also extract the values that I have in mind. So first things first, I'll put a link somewhere there in the description later on how to instrument your JMeter with OpenTelemetry. That's gonna be helpful because I want to also ship all the details, everything that my browser has done, to the OpenTelemetry, to my OpenTelemetry collector, so I can troubleshoot later, and then I can also go from whatever happened on the browser back to the backend of the services. That's one thing that I'm really missing from all the OpenTelemetry stuff. There is no stable browser monitoring yet. There is no stable ROM that I can just drill from the end user perspective to the cause on a backend. Right, and I'm not sure whether that's something that will be fixed or introduced in some time, but that's really a problem that I'm seeing myself, that there is no correlation, no easy correlation between the front end and the back end right now with OpenTelemetry. I've seen some APMs doing that pretty well, so I really hope it's going to be fixed, but right now the focus still seems to be on the backend side. It seems like we're back in 2008 when the web pages were still static, and we just expect a linear correlation between the server-side response times and your front-end response times. But okay, so we'll be using the Selenium plugin, and also I'm just going to be instrumenting the OpenTelemetry in here, so I can send the spans from my browser, so straight from my WebDriver, not straight, but whatever the browser is doing, I will be sending them straight to my OpenTelemetry collector. Not sure even how to pronounce it, but the ones I'm going to be using is Synos. I don't even know how to call it, sorry. But yeah, that's going to be my my attempts. So first, you need to configure your Chrome driver config. I've just downloaded my Chrome driver, so you know, just follow any instructions on how to set up your Selenium WebDriver. I have also put the option to load my extension, so the JS files that I have built, they are here. So I'm just gonna using my own extension, Web Vital Selenium, and I'm also going to be opening the DevTools for tabs. I think this one was required to run a remote DevTools session between my JMeter and the Selenium WebDriver. For the rest of options, I don't need anything else, so they are just blank. But the important part is to actually load the extension here, so that I can access the JS library. And then comes the good stuff. So it's set up auto, but actually should be set up auto and core web vitals. Right, that's my step here. So most of the instrumentation here really is set up in the first sampler. This could be JSR223 sampler as well, but I want to also access the browser here from the WebDriver sampler, so it's easier that way. And I have a few libraries here. So I need to access the network package from the Selenium DevTools. This here is important. The version of the package needs to match your major version of the browser you're using. That's very important. Otherwise, you would not be able to intercept any calls that your browser is doing. So this here, I'm pretty sure it could even do that, like version parameter. So browser major version, and I can just go with the 1 to 5. Oh, sorry, I'm just 1 to 5, and I think this should work as well. So we can just, and there is a parameter default whatever, and they can override them anywhere. This should work, but I'm not gonna do it right now. I know my browser right now version is 1 to 5, but it would be problematic when you try to update the versions. You'll also have to update the versions of the browsers and in here in the code. I think my camera is going down. Just a second, let's see if I can just access that somehow. My camera hub is down. What's that? Small technical issues. I'm sorry, it's my first live stream, so expect these for now until I learn this whole stuff here. Let's see if I can fix it shortly. Okay, I need to fix the camera setup. Okay, this looks better now, I guess. Camera is on. I'll probably have to play around with the setup here somehow. Okay, the camera hub, this one's working. Okay, sorry for that. So I'm just gonna stick around with the fixed versions, but if you want to update your browser version in the future, that's probably parameters should work as well. So also I'm gonna modify the headers. Modification of the headers will be necessary to propagate the context of your traces. That's going to be important also as well. 1 second, let me check if I can put up here a let me check if I can see the chat. Oh, okay, there's nothing in chat yet. But in case you guys want to ask questions, just do it. Should not be a problem. I'll try to address them. Okay. So let's go back. So the headers I will be modifying. See, that's again something with my camera. I'll have to set up somehow to stop shutting off. Sometime I think that's the culprit here. I'll have to address these somewhat. Okay, so headers, I will modify the headers to get the traces and to propagate them to my backend. So my OpenTelemetry collector will know and will correlate the backend calls with the front end calls. So I could just drill down straight from the front end to the backend. Consumer, this is an explicit declaration of the consumer interface. There is also a bidirectional consumer interface, and I think it's going to be the most recent one. So, but that's just a technicality right now. I will be acting on 3 events. So first, I think actually 2. When you communicate with the browser over the DevTools interface, especially with damn it, I think my camera doesn't like me now. I think I have to fix that somehow. Not sure why it happens. Have to go through menu and try to fix that. It says running on my scene. It's charging, but it is shutting down. I think that's a setup here. Internal temperature is high. Okay, I think my camera is finally showing some symptoms. You know what? I'm just gonna switch it to my laptop camera then. And I'll have to solve the temperature issues later. It is very hot in here today. So I'm just going to switch my internal device right now. Yep. Okay, this one's a bit different, but I think I can work with that. Okay, so I'll be acting on the request intercepted. This is the step where I can actually modify the headers, and this is also where I'll be tracing the calls to create the spans. There's also a response received signal sent by the network package. So whenever I get the response back, when the browser gets the response back, I can also modify, I cannot modify it, but I can close the span. So in the steps between the request intercepted and response received, I can create my own internal span and then forward it to my OpenTelemetry collector, right? With the request interceptor step in also serving the context propagator for my tracer. So in order to do that, I have to keep track of the spans that JMeter has created. This is actually an anti-pattern, I guess, from the perspective of the OpenTelemetry, but I'm also not doing the standard implementation here. So if it was happening on the browser level, I think the context should be enough to do that. And you could track the calls synchronously, but since we are just intercepting these, the best way so far I could find was to keep track of all the spans I have created and then referencing them if I have a match of between the request intercepted and response received. The browser will give me the request ID, which should be matching, and if I don't have a matching one, I'm going to show you how to handle that as well. So I also have to create the context, at least access the context. Also keep note that my implementation is not say up to the best standards or up to the book with the OpenTelemetry, so I'm cheating a bit here. My spans do not go hand in hand with the current context, but that's also works for now, so I'm leaving it like that. I need to reference my tracer, and also the variables. I have to keep the reference of all the spans. This is an array, sorry, not array. This is a map of all the spans. So I reference the tracer here. I have to create a session for the DevTools so that my JMeter can communicate with the DevTools, so with the developer console of the browser. I have to enable some network options so that I can actually intercept the calls. This here, this piece of code, I actually don't need it anymore. So I can just delete that. I can just delete that here. Do not leave any commented code in the code base. That's practice. So first things first, adding the listener, and the event here is request intercepted. And in here, I'm explicitly specifying the new customer. So as opposed to bidirectional customer, this in the later versions that will not be possible. So you have to use the bidirectional customer, but right now it works. So it's good enough for the POC. And yes, this is the event when what the browser will emit when it starts, when it wants to send out the call to the backend or to whatever service. And I'm overriding here as a customer, so I have to accept this request here. I need to create the span myself, so I'm starting the span here. This is an OpenTelemetry span, so this right now already keeps track of the timings in here. So in OpenTelemetry collector, this will show up here as a sum span with a yeah, okay, so I'm going to show the function later. This is also a bit of messy code, but what it does is I'm putting here a reference to the span by the request ID, so I can refer it to the on all the events. A bit of debugging here, so debug logs. If you've ever worked with JMeter, you know that debugging is basically non-existent here. Logs is really the best way for you, the fastest way for you to debug any stuff. Unless you guys know any other better way to do that. Then there is the I'm adding the OpenTelemetry headers. So my implementation of OpenTelemetry already injects the trace parents, so the main context of the trace, into the variables. So whenever I have a like OpenTelemetry start span preprocessor, this would also inject my trace ID here in the comments. I can already use that, so it's already injected. So I'm creating a header map and create a headers object. And after I have injected the trace parent, so the header for trace propagation, I'm also sending out here a like continuing basically the request that I have intercepted myself. So I get the interception ID and modify only the headers, right? If you just leave these fields empty, they just stay as they are. But also if you add these headers, I'm only here defining the trace parent, they will be added on top of the existing request, right? So you don't have to worry about copying over events, copying over the headers. This piece of code, this the default send method, the continue intercept request, should only add new headers or modify the existing ones. It doesn't like empty out the existing ones. So again, when we are intercepting the request, we create a span and we add the header to the existing call, right? And we continue with this intercepted request. So this happens immediately. There should be no major delay with that, and it should be fine, I guess. What else would be there? Okay. Nice. So the other one is a listener for a received response, and that's a thing. When I already have a response back, I can I have to first stop the span that I have created, because that's where my timing has ended, right? And also okay, so you see here I'm just getting the request ID, but I have to end the span that I have created, so they don't stay in my memory, right? Because whenever you start a span here, the OpenTelemetry library will keep track of all the existing ones, and they will be accumulated on your memory. So make sure you actually end these, and then you can get in the accurate measurements of your calls to the backend from the front end, right? So the thing here is you're gonna have a listener, response received, and we're just gonna end the span. That these are my custom functions, and this end span function is checking first whether I have seen this request ID. If I have not seen this request ID, based from what I've seen so far, I haven't really touched on the I haven't seen much of the documentation, just the Java docs of this method and of the signal. But from what I have seen so far, if I get the response, but I haven't seen the request being sent from my browser, this would be most likely a cached call. Right, so you see when your browser does a call to the backend, you're gonna see them, popping up. They're gonna take some time. They're gonna, measure the connection time. What's the time to first byte, whatever. But if it's just getting from a memory, they will not emit a signal that the request will be sent, right? So the request intercepted signal will never be emitted for this particular end call. So yeah, that's the main idea. So based on from what I've seen so far, they would only be resources getting from a memory. So I'm just treating this that, and I'm just starting them as they go. So I still want to keep track of these calls, because why not? I want to see what my browser is doing, and my OpenTelemetry collector. So I'm just keeping them as a immediate fire and events, right? So so I'm just getting the request ID and the response object, and I can create the span, which I am going to name as, where's this function here, start span. So I'm just going to name it cached plus the URL, right? So I know that I haven't made this call anywhere. I am just keeping track that, hey, this came from the cache, so your browser didn't do any work here, right? I'm also not expecting it to be, say, propagated to the backend, so that's also fine, right? And also in here, I have to enable the network functions of the browser, so I'm doing it right now here. And that's the preliminary setup of the functions. So in here, I'm just connecting the signals. I'm connecting the browser with my JMeter script, so I can act on all the signals sent from the browsers, right? So they will handle the call interception. So any calls from the backend, they will be intercepted. They will create the spans for me. They will also end the spans, so they will measure the timings, and on top of that, they will also propagate the contexts of the OpenTelemetry to the backend as well. The next part is actually making any calls, so operations of the browser, because so far we have a let's say we are just sending stuff to the OpenTelemetry, but the core of this implementation was to measure the core web vitals, right? So let's see how it goes. We have already loaded the extension for the browser. So this here would be a simple script that would also get the web vitals in here, right? So script is very simple. I'm just starting samples, I'm ending the sample results. That's also good. This here piece of code only opens the browser. I'm not sure that it's actually a correct. No, this would not be a correct one, because if you only do the browser get, it only opens the page, but it doesn't wait for anything, right? I'm trying to open the dev perf ops in here, and normally if you open a page, you should also assert or wait for some event or some object to happen so that you know that the rendering is complete. If you only send the browser get signal, it will only start getting this page, but it doesn't measure anything, right? So, and that's when you try to really load test a page, and you want to measure the rendering also. You want to include your rendering measurements to the browser. The thing you have to do, you need to make sure that you also measure the rendering side from the browser, right? So if I open the devperfops.org, probably you'll have to add some event here or some wait. So Twitch here, I want Twitch. If we, for example, go to devperfops, right, you need to make sure that this page has been fully rendered, right? So yeah, for example, you want this object to be completed, right? So that's the best, like the easiest way so you can do. Inspect here. I want this button, because it's a button here. I want this to be a clickable. So right now I'm just making this up, but I can just copy the XPath from the browser, and that's my XPath here I'll be using. I'm pretty sure I have some WebDriver. Wait, yes, I can expand here. I need to add a WebDriver wait event here. I think I have to also import these libraries so that you get the correct measurements, right? So I have the Selenium by, and I can, this is the WebDriver event, so I'm timing out after 10 seconds. For front-end testing over a load test, I think explicit waits would be better than the implicit ones, but the decision is really up to you. Okay, and I want this element to be clickable, right? To escape these. Yeah, and now the sample here will wait until it's actually finished rendering, and I can perform some actions on this page. And in here, after I have finished actually measuring stuff, I can access the scripts. I can execute the script I have attached to the window object, which is called the get core web vitals. And I'm not sure I am. Oh yeah, I'm also printing them somewhat, and this is the format they are being extracted as. So I get an array, a map of the core web vitals. So from there, I can just access the key sets, I can access the objects, and I'm entering these as the attributes for my current span. Right, so for the actions I'm extracting, for example, I'm opening up the dev/perf page. This will be my attributes. I'm going to be adding an attribute of CLS, and it's going to be one. Yeah, it's going to be very low CLS, and yeah, that's basically it. So for any core web vitals that I will be measuring, they will pop up here as the attributes for my span, and that's how I will track that's how I will track the change of the core web vitals and the impact of the backend performance on the front end. Okay, so now if I maybe start up the script, let's see if I can do that here. It starts, it does some actions, right? It did some stuff on the back end. It was very fast. Normally you'd also put some pauses between the actions so that you can, that they're actually measuring stuff properly. Otherwise you see, for example, the CLS is growing here all the time, right? So you have some actions there. You have a time to first byte, LCP, CLS. I haven't seen an INP anywhere though, but it should be actually popping up because I have made it click something. That's weird. Oh, hi, Ivan. Why do you have to go? Stay with us, please. Okay, so I just spotted him in the chat, and so these are the core web vitals I'm extracting here, and when I open my, let's see if I can do. Oh, I of course forgot to start my Synos instance, I think, because my desktop isn't running. Containers. Yeah, I have to start. Let's see if it's gonna start or not. Oh no, I have deleted one of the collectors. That's a shame. I have to install this again. Okay, let's do this. You know what? Let's do this. I don't think this would take me a while, too long. I'm just gonna delete the ClickHouse because I just deleted some of the instances, some of the containers that were not in use when I ran this this instance, but it looks like, yeah, I just want to delete this thing here. Just gonna refresh somehow. Just need to refresh. Oh no, I cannot just do the compose. Damn it, I think I have to delete them one by one. That's my bad, sorry. I came unprepared for this, I guess. Okay, now it's done. I can install the Synos again. This shouldn't take long. Let's see. Why is that not here? Yes. I am pretty sure I did have an install script here, unless I missed that. Nah, it's not there. Whatever happened to, that's weird. Yeah, of course, it's a live demo, so no wonder something good happened here. I was pretty sure I did have it somewhere there. You know what? Let's try just install it again. Go with instructions. Ah, okay, so it's in deploy directory. Okay. Ah, of course, the wrong terminal. Okay. This guy's pulling in. I'm just gonna install it from scratch. Should not take long. Okay. I think this is still starting. The installation went pretty smooth last time, so I guess it shouldn't be any different now. Container status. Okay, still in progress. Front end. Okay, it's up. It's up. Okay, I think it's up now. And okay, I'm already logged in, so that's good. That's fine. So now if I just restart my JMeter, restart. Open recent. Okay, so my sampler, and if I started right now, this should already send some samplers to my collector. Okay, I have to stop some of the default containers. Pretty sure I just have to stop them. Load the low-cost package. I don't need that. I don't need any low-cost packages. I don't also need a example containers. I'm not sure about the others, but I don't want this noise here to show up here on my platform when I use that. Okay, unknown service Java. If you want to name this service, I think you have to just define a I think you just have to define the service in the environment in the environment variables, but other than that, it should be fine. Okay, so for example, here we have opening of a dev perfops page. What? No, the easiest way would be to show you the services. Okay, I want a click manifesto, because this one is going to be a representation of what I also saw in my browser, right? So you can just go to network tab and see these calls as well, and compare them one by one. Okay, so in this case, I don't see the spans of the. Okay, these are the spans of the created by the browser. It looks like the browser was still doing something. Okay, I don't think that's a good example because I was clicking something on the page. Let's try this again. Just gonna shut down here. Okay, what I want to show you is a correlation of what we're gonna see in the sine of traces versus the browser, whatever the browser is reporting. Okay, so this is the rate here. Clip manifesto. Okay, this code is not available yet. This is also a bit tricky because a Java, the JMeter doesn't send these immediately. They can also batch the traces, so they will not be available right away. Okay, this I think was the one I've opened here. So most of them were cached calls, right? So the first, you can see here, that was just an opening of a manifesto, so the first call. Then we had some cached, so from calls from the memory. So there was some, what was that exactly? So PNG, so some static. Okay, so the CSS files in here, and to support my theory on loading it from metrics. If I show you this, so for example here, this cookie bar, so see here, this came from memory, right? So there was some logo PNG also coming from memory, stuff like that. So, and the time was 0 milliseconds, and exactly the same here. So just, actually the fonts also probably didn't count that. That's weird. Bit of unexpected. Okay, so it looks like this thing here adds a few milliseconds for each call. I'm not sure why this happens. Because it should close the traces immediately, so the spans immediately. I'll have to look at what's the delay was caused by, but I don't think it's going to be much of a problem. And there's also, if there's not cached call, for example, the COP, the fonts, Google APIs, this, for example, took 81.99 from the JMeter perspective, right? And if we look at the same call for the fonts, it's which one is that here? API Sparlow condensed. Okay, I think that's gonna be easier here. This guy here. Okay, that's the one here. 64 milliseconds. I'll have to check what's the difference between the delay here. It may have been that this call has been queued on the browser side, and I've captured the queuing time, but not the execution time. But I'll have to check that as well. So there's a bit of discrepancy here, and of a like a few milliseconds. So I guess 17 milliseconds. So I'm gonna have to check it as well. But yes, that's about it. So you can see here we are capturing all the calls that the browser has made inside the OpenTelemetry. So I think there is no available solution for that yet, at least for the commercial customers. But it's definitely doable. And yeah, once I solve these discrepancies between the numbers, which are not that high really, then I think we can just roll this out as a plugin or some extension for the JMeter. But before you start using that as a fully load test of your own, remember that browsers, they are expensive in terms of hardware. So you will probably know, and if you've tried to implementing all front ends load tests, you know that the hardware capacity for that is huge. So you cannot just throw, you know, thousands and thousands of browsers without having a performance penalty affecting your response times. So, and that's, you know, because like your browser needs to have at least a single core and a 1 gig of available RAM to run your web page like smoothly, right? So your customers, for example, will not be, you know, having multiple browsers at the same time. They will have, no, if they do some actions, they will probably do it on a single process. You know, there might be something running in the background, but when you introduce too many browsers for a single CPU, you're gonna see them skewing your results for the worse. Right, so all of your results will be inaccurate, and the measurements also will not be accurate because you cannot just, you know, put that. You cannot just throw, you know, thousands of browsers on your machine. And this is exactly the reason why most of the load testing software is working on the protocol level, right? Because it doesn't have to account for the rendering, it doesn't have to run its own JavaScript, virtual memory, virtual machines for execution. It doesn't have to, you know, utilize the GPUs. It is just a roll call to the backend servers, and, you know, roll measurements of the HTTP calls. Mostly it's HTTP, but it doesn't have to do everything that the browser is doing on the backend, right? So, but having a hybrid approach, a hybrid testing. For having at least a small subset of browsers that are measuring your front-end performance would be a benefit for all of you guys. So, you know, if you, for example, only have run a front-end like core with vitals assertions and you have only done a back-end testing, those two may not give you the accurate results if you combine the two. So if you try, for example, you know, put the users on a heavily loaded servers, they will have greatly different response times, right? And if you Google tracks your core web vitals during those load tests, not during the load test, but during the high load of your servers, when they will start responding at the very high, at the higher rates, you may look at your Crocs data and see that it's vaguely different from whatever you were reporting initially. There's no questions for now. There is nothing from the audience, so I guess I'll be finishing. But yeah, if you have any questions about that, just drop them here in the comments. You can also find me on LinkedIn somewhere, and yes, that's it. I will try to fix the measurements here. So the difference between the cached calls and also the difference between measurements at the front end. My first guess is that I'm trying to measure these requests before they, like once they are formed, but not when they are queued for the execution, but not exactly when they are being executed, right? Since I'm still given an option to modify these requests, that's my best guess right now. That's the case. So I'll try to fix that, and I will also fix my camera so that it doesn't turn off when I'm trying to recording. So yes, thank you, and I guess that's it for today.